What you're about to discover in this video is based on real data, direct measurements from spacecraft that cross the outermost edge of the solar system into interstellar space. NASA's Voyager probes didn't simply drift across that boundary, they reached it definitively. They found that the solar system is inside a vast magnetic bubble created by the sun known as the heliosphere. This invisible shield protects us from high-energy cosmic radiation that fills the rest of the galaxy. But like any bubble, it has an edge. When Voyager crossed that edge, the change wasn't subtle. Solar particles vanished almost instantly. Galactic radiation spiked. That sharp transition captured by Voyager's instruments has reshaped how scientists define the true boundary of our solar system. When Voyager 1 and Voyager 2 launched in 1977, their mission was straightforward: visit the outer planets, send back close-up data. Jupiter, Saturn, Uranus, Neptune. No one expected them to keep going for nearly 50 years, let alone leave the solar system. But as the spacecraft moved farther from the sun, something interesting began to happen. The solar wind seemed to weaken, and the boundary of an invisible bubble began to appear. The sun constantly blasts charged particles outward, creating a vast magnetic bubble called the heliosphere. This bubble encloses all the planets, extends far beyond Pluto, acts as a shield against high-energy radiation from the galaxy. Where that bubble finally gives way to interstellar space lies a boundary called the heliopause. Before Voyager, scientists thought this region would be thick and chaotic. Instead, Voyager found something shocking. In 2012, Voyager 1 recorded a sudden event. Solar particles dropped almost to zero. Galactic cosmic rays spiked instantly. Plasma behavior changed in minutes. There was no gradual transition. Voyager crossed the heliopause through a remarkably thin boundary, like passing through a wall rather than a fog. In 2018, Voyager 2 crossed the same boundary from a completely different direction. It saw the same thing. 2 spacecraft, 2 crossings, 1 unmistakable result. Just inside the heliopause, both spacecraft detected something unexpected. A compressed, heated layer of plasma. Temperatures were higher than models predicted. Particle densities were higher than expected. This region acts like a pressure barrier, where the sun's outflow piles up against the surrounding galaxy. But that wasn't the strangest part. Scientists expected the sun's magnetic field to collide with the Milky Way's magnetic field at the boundary. Instead, Voyager found that the magnetic field direction barely changed at all. That suggests magnetic reconnection, a process where solar and galactic magnetic fields link together instead of clashing. The heliopause is not only a border, but an active, living interface between our star and the galaxy beyond. Voyager also revealed something critical for Earth. The heliosphere acts as a powerful radiation filter. It deflects and slows a huge fraction of galactic cosmic rays particles energetic enough to damage DNA, disrupt spacecraft electronics, strip atmospheres from planets. Without this magnetic bubble, Earth would exist in a far harsher radiation environment. The heliopause doesn't just define where the solar system ends. It helps explain why the inner solar system is stable enough for life to exist at all. Voyager's measurements also showed that the heliosphere is not symmetrical. Interstellar gas is denser on one side, squeezing the bubble unevenly. Plasma waves detected by Voyager reveal ripples and distortions, evidence that the solar system is constantly interacting with its galactic surroundings. As the Sun orbits the Milky Way, this boundary shifts, which means Earth's radiation environment has changed before and will change again. These discoveries reshape radiation models for deep space missions, planning for Moon and Mars astronauts, our understanding of how planetary systems survive in changing galactic environments. Voyager has given us humanity's first direct measurements of interstellar space, but it can't keep going forever. The short answer is yes. Voyager's instruments were designed in the 1970s. Engineers are now shutting down systems one by one just to keep the spacecraft communicating. Every signal it sends back is precious and temporary. There is no modern replacement waiting beyond the heliopause. Many scientists argue it's time for a dedicated interstellar probe built specifically to study this boundary and what lies beyond it. Because Voyager didn't just cross the edge of the solar system. It revealed that the edge is complex, dynamic, and alive. If you genuinely enjoy exploring the universe and its mysteries, consider subscribing. It helps us keep going. The solar system is a magnetic bubble drifting through the Milky Way, shaped by forces far larger than the Sun itself. And for the first time in history, we reached where the boundary is. Should humanity send a new interstellar probe to follow Voyager? Or let this 1977 spacecraft finish the journey alone? Tell me in the comments below. And with that said, subscribe to the channel and see you in the next video.